Let's consider conversion of galvanometer to voltmeter. You know too well that galvanometer is used to measure small amounts of current, while your voltmeter is used to measure your potential difference or your voltage. Now, if you want to convert galvanometer, that is, if you want to convert galvanometer to a voltmeter, that is making a galvanometer to act like a voltmeter, what do you need? The only thing you need to do is you have to connect a high resistant resistor known as multiplier. Now, this high resistant resistor is connected in series with the galvanometer. And so whenever you connect it now, so this Rm means what now? Your multiplier what? Resistance. That is Rm here means your what? Your Rm is just meaning your what? Your multiplier resistance. Multiplier. Resistance of the multiplier. That's what we mean by this. Now, and the Rg here is the resistance of the galvanometer. This Rg here is what? Galvanometer resistance. Your galvanometer resistance. Okay, now whereby if you look at this now, you discover that we also have voltage across this. So when you connect this in series, look at this carefully. This is what we call a series connection, whereby this line, whereby the connecting wire enters here and leaves here and enters here and leaves here. So this is a series connection, and we are going to have voltage across each of them. We are going to have voltages across each of them. So we are going to have voltage across this resistance, this multiplier. We also going to have voltage across this galvanometer as well. Now, I believe that you might recall, or you will recall that whenever you have a series connection like this now, in series connection, in series, what happened in series now? In series connection, your current is what? Current is same. Current is always the same, but current is the same, and voltage differs. Voltage differs. Voltage differs. Now, so for that reason, so let us derive a formula that we can use to calculate the multiplier. Now, the reason why I want us to derive this is for you to be able to remember. In case you forgot the formula, you can derive it yourself. Now, let's go and see how we're going to derive it now. First of all, you need to take note of one thing. And what is that now? Now, since the voltage across this multiplier is different from the voltage across this galvanometer, if you add both voltages together, you are going to get what you call a total voltage. This voltage is different from this voltage. So for that, we can say that our total voltage, that is if you add both of them together, is going to be your voltage across the multiplier, which is your Vm, plus voltage across the galvanometer, which is Vg. Now, voltage across the multiplier, according to Ohm's law, remember Ohm's law? Ohm's law states that V is equals IR. Now, for that reason, what is going to be my Vm? My Vm is going to be what? Vm is going to be what now? IRM. Now, the reason why I'm writing under I here is that I told you before that in series connection, the current is what? The same. So I'm not going to specify whether it is Im or Is. I'm not going to specify anything there. Rather, I am going to write only I. Now, for the R, I'm going to write Rm. So which means, I'm supposed to put, let's put something here. Here is going to be our Vm is equals IRM. That is your voltage across your multiplier is equals I times the resistance of your multiplier, high resistance multiplier. So remember that this multiplier is always of high value, high resistance value. So that is your multiplier. Now, what is going to be my Vg? I'll just say that my Vg is equals what? IRG. Now, since I've known this now, I can say IRG. Okay, let me just use a small letter for this, please. Let me use small letters for this. IRG. Okay, let me use small letter for this. IRG this way. Now, what is going to be? So from this that I have now, what next am I going to do now? I'm going to say I'm going to make my VM the subject since we are looking for that of the multiplier. If I make VM the subject here, I'm going to have VM is equals what now? This going over to the next side is going to be V total minus what? VG. What is my VM? My VM is equals to, that is VM is equals IRM. All right, IRM is equals my V total minus what is my VG? My VG is equals to what? IRG. So since I'm looking for my RM, I'll divide both sides by what? By I. I'll divide both sides by what? By I. You cancel this and you cancel this now. What do I have finally now? I'm going to have RM is equals my V total minus IRG all over I. So this is the formula for calculating your multiplier. So the next one I'm going to talk about is your shunts. To convert a galvanometer to shunts, what do we need to do? The only thing we need to do is to connect a low resistance resistor in parallel with the galvanometer. This low resistance resistor is called a shunt. It's called shunt. Now, let's look at the formula that we can use to calculate our shunts or our low resistance resistor. Now, this is the resistor we're talking about. How to calculate it, the formula that we need to use. I am going to derive that now. Now, let me show you what to do. If you are to derive that now, you need to take note of one thing. And what is that now? You always remember one thing, that for this now, since this is parallel connection, current to do what? Current will differ, and the voltage should be what? Will be same, since it's parallel connection. So the current will differ, and that is why if you look closely, you will discover that our current here, we have I total is equal, as in I total was split into two. We have IS and also IG, but both of them all combined together. Both of them combined together will give you your I total. So I can just say that my I total, my total current, is equals my what? My IG plus what now? My IS. That is both of them, my IG plus my IS. All right, so what is going to be my IS? What can I say as my IS now? My IS will be equals I total minus what's IG. But there's something that I need to remember. What do I need to remember? Now you discover that since both of them have the same voltages, so what will I say now? Since they have same voltages, what will I say now? I can say that the voltage across that of my shunt is equal to the voltage that of my galvanometer. Yes, I can say that because both of them has the same voltages. The same voltage that went into here is the same voltage that went into here, but the current will differ. Now, since I have known that now, what will I say now? According to Ohm's law, I remember that my V is equals my IR. Now, since it's all about shunts, what will I say now? I'll just say that V is equals to, what is my I? My IS, supposed to, okay, let's say IS, RS is equal, that is IS, RS is equals IG, RG. So I can say that now. Where did I get this thing from? I remember that according to Ohm's law, I know that V is equals IR, whereby since I'm talking about that of the shunt, I'll just say that current of the shunt times resistance of the shunt. I have IS, I also have RS, so I have it here. Then here, I also have my IG times my RG. Where did I get that now? This is the current of the galvanometer and resistance of the galvanometer, and I also have IG and the resistance of the galvanometer in the diagram here. So what will I do next now? I'll remember one thing. What will I remember now? I remember that what is my IS now? My IS is equal to I total minus IG. So I can have it here to be what? IS, my IS, that is my IS is equal to my I total minus what? Minus my IG, all brackets my RS is equals IG, RG. This is RG. Let me write it properly. RG. This. So let's finish up here. Let's finish it up here. Okay. Let's finish up. So what am I going to do next now? I'm looking for my RS. That is, I am looking for the formula I'm looking for is for this RS, the resistance of the shunt. So because I am looking for that now, what will I do now? I'm going to make it the subject, and if I make it subject, I'm going to have it as RS will be equals what? IG RG all over what? I total, this is my I total minus my IG. So this is the formula to calculate your shunts. Now I'm going to bring us questions and let us see how to solve these questions under shunt and multiply. It is very simple and not difficult at all. Just the only thing you need to do is, when I present this question, you just listen carefully. Let's consider this question that is presented to us. Now we have the question that says a milliammeter. That milliammeter is the same thing as a galvanometer. Now, a milliammeter of resistance 5 ohm. So the resistance of this galvanometer or milliammeter is how many ohm? 5 ohm. Let's continue. And full deflection of 50 milliampere. So our full scale deflection, let's say full scale deflection of 50 amp. So our galvanometer, normally galvanometer is always measure current, so it's always in current. So for the current of our galvanometer is how many now? 50 milliampere. How did I know? Since they say full scale deflection, and the only thing that will do that deflection is your galvanometer, and your galvanometer only measures in ampere. So but we want to convert it to be able to measure as a voltmeter or serve as a voltmeter. So whenever you hear that word full scale deflection of any current, they call after that full scale deflection is always the current of the galvanometer. All right, okay, is to be used to measure a potential difference, okay, of how many volts? 50 volts. Okay, they say the resistance of the multiplier should be, normally if I look at this question, even if they did not mention the word multiplier or shunt, how will I know that this question is shunt? How will I know that this question is multiplier? It's very simple. The only thing I need to do is I'll look at this question very closely, and I'm going to look for one thing. If I see anything volts in the question, I will automatically know that this question is about multiplier. I hope you are getting what I'm saying. Listen carefully. So if I see anything like volts, like the way I'm seeing right here, so even if they did not mention multiplier, if I see anything volt in that question, automatically I'll grade this question under multiplier. And quickly, I'll write out the formula of multiplier, which is my Rm is equal to my Vt minus my Irg all over I. So I'll write out my formula, and you all remember how we got this formula. So whereby my Rm is the resistance of the multiplier, which is our Rm. My Vt is my total voltage. My I is my current. And normally this current is supposed to be, this is current of the galvanometer. Let me put it clearly. Let me state it clearly. This is current of the galvanometer, and Rg is my resistance of my galvanometer, all of my currents. So all over the currents or currents of the galvanometer. Okay, let's just put it as currents. Let me leave it as current. It's okay, whether galvanometer or not, it's still going to serve us. All right, so now let's point out what we have here. Now I said that a milliammeter of resistance, which is our galvanometer of resistance 5 ohm. This 5 ohm is called the resistance of the galvanometer. So resistance of galvanometer, known as Rg, is equals 5 ohm. How did I know it is 5 ohm? They mentioned it here. They called it a milliammeter, and I told you that you can call it either milliammeter or even galvanometer. They say that this milliammeter has a resistance of how many ohm now? 5 ohms. So resistance of our galvanometer is 5 ohm. I proceed. Now you see that it has a full scale deflection of 5 milliampere. So our current that we have here is how many? The current that we have is 50 milliampere, which is something as 50 times 10 raised to the power minus 3 ampere. Where did I get 10 raised to the power minus 3? Milli is 10 raised to the power what? Minus 3. So that is it. Now what next am I going to have here now? Is to be used to measure a potential difference of 50 volts. So my total voltage is how many now? My total voltage is equal to how many volts now? 50 volts. That's my total voltage. And I'm asked to get the resistance of my multiplier, which is, I am looking for my what? My Rm, which is unknown. So what will I do? I'll fix my parameters here now. So solution, I'll start with that. I'll quickly say that my Rm is equals, what is my V total? 50 minus, what is my I now? 50 times 10 raised to the power minus 3. And what is my Rg now? Times 5. Let's put all this in inside brackets. All over 50 times 10 raised to the power what? Minus 3. So I'll just say that my Rm is equals 50 minus, okay, so I say 5 times this, I'm going to have it as 250 times 10 raised to the power minus 3 all over 50 times 10 raised to the power minus 3. So this is Rm is equal to 50 minus 10 raised to the power minus 3. I have it as 1, 2, 3. So which is 0.25 all over, okay, I have it as 1, 2, 3, 0.05. So this is what I have. And I'm going to get my calculator and solve this out. So using my calculator here, I'm going to have it as 50 minus 0.25 is going to give me 49.75. This is 49.75 all over 0.05. So if you divide this in by 0.05, what is going to be my final answer? My final answer is going to be 995 ohms. So that is my final answer. And all right, now let's consider this second question. Now this second question says that a moving coil galvanometer of 300 ohm. So 300 ohms, which is the resistance of the galvanometer. Take note of that. Remember that anytime you see after the galvanometer, you see something like the resistance, that resistance is always the resistance of the galvanometer. All right. Okay, 300 ohm resistance gives full scale deflection. Sorry, gives full scale deflection of 1.0 milliampere. Now, who owns this 1.0 milliampere? This 1.0 milliampere is for what? It is the current of the galvanometer. It's always the current of the galvanometer. So how did I know? Read along. You can read again. I just say that a moving coil galvanometer of 300 ohm, I've already said that this 300 ohm is the resistance of the galvanometer. So resistance of the galvanometer is 300 ohm. Resistance of the galvanometer is 300 ohm. Resistance gives a full scale, the same galvanometer gives a full scale deflection of how many? 1 milliamp. The same galvanometer did that. So because of that, that is going to be what? Current of the galvanometer, which is equal to 1.0 milliamp. Then another secret that I need you to take note is basically current of this galvanometer, it's always a milliampere most often. It's always either 0 to 10 milliampere, 50 milliampere, it's always a milliampere. Highest is always a milliampere. Yes, it can be a 1, but no, it doesn't. It's always a milliampere. So that's one of the things that I will tell you. So immediately you see that, you can consider that. Read along carefully and you can consider that. All right. Now they say that the resistance R of the shunt, we are looking for our R of the shunt that is required to convert galvanometer into a 3.0 amp. That is our total current. Our total current, that is total current that we're going to have here. the total current is always larger than the current of the galvanometer, so it's always 3.0 amperes. So one thing I need you to take note of is this. Always bear it in mind that the current of the galvanometer is always less than the total current. So even if you don't know, even if you cannot identify any of these parameters, take note of one thing. First thing first, I say that any resistance that you saw around or after that galvanometer is always resistance of the galvanometer. Resistance of the galvanometer. That's number one. But even if you do not see any resistance, even if okay, that is always the resistance of the galvanometer, because it's possible for them to give the resistance of the shunt and ask you to get the resistance of the galvanometer. All right, now if you look at this now, what do we have here now? I also told you that the current of the galvanometer is always less than the total current, and we are asked to get our resistance of the shunt. How do I get it? It's very simple. Now listen. Now this is what you're going to write. I'll do my solution. I'll just say that my RS, which is resistance of the shunt, is equals to what? What is my IG? My IG is equals to 1.0, and I've not done my conversion. This my 1.0 is something as 1 times 10 to the power minus 3. Why? Because of milli. Please bear it in mind that 1.0 and 1 are the same thing. So 1.0 is the same thing as 1. This milli is 10 to the power minus 3 ampere. So coming to this place, I'm going to say 1 times 10 to the power minus 3. Alright, times what is my RG? My RG is 300, okay? All over, what is my total current? My total current, as we have here, is 3 minus what is the current of the galvanometer? The current of the galvanometer is how many now? 1 times 10 to the power what? Minus 3. So let's do our calculation. I'll just say that my RS is equals, if you go by this now, this is, if you go by this now, this is 0.00, that is, have it as 12001 times 300 all over, this is something as 3 minus 0.001. Nice. So let me get my calculator and let's solve together as usual. So let's use our calculator to calculate that. I will just say 0.001. Okay, so 0.001 times 300, which is something as 3. Okay, 0.3, sorry. It's something as 0.3 all over 3 minus 0.01, which is something as what? 2.99. So if I divide this, I have 0.3 divided by 2.99. So the answer is going to be what? 0.100. This is your ohms. So this is your final answer. So that is it. You will now see that to solve this is